One application of the use of electrical fields and magnetic fields is what we call a velocity selector. In this particular case, what happens is you have particles being generated with different velocities, and what we do, we make them move through a region where we have both an electrical field and a magnetic field, both an electrical field and a beam. Now, the idea here is we have them such that the force due to the electrical field, or what we call as Fe, is going to balance the force due to the magnetic field. When both are balanced, the charge is going to move on a straight line. If they are not balanced, the charge is going to move either upward, but anyway, we can subject the charge in this yellow region here to an electrical field or a magnetic field. Now let's check the effect just of the electrical field. If I have a negative electrical field, it's a positive charge, okay, and then the force is going to be in the same direction as the electrical field, so you see it pointing down, that purplish arrow. Now let's have the electrical field in the opposite direction, and the force should be upwards in the same direction as the electrical field. Now what I'm going to do is have no electrical field, so the charge is going to move on a straight line. But then I'm going to subject it to a magnetic field. Now here I have a positive magnetic field. Notice here, due to this magnetic field, the charge is bending downwards. So using the right-hand rule, let's replay it. So it gets there in the middle and we pause it. Okay, now this is your thumb, this is your force. It's a positive charge. So that says that the magnetic field is pointing perpendicular to the screen and out of the screen. Now let's have the magnetic field in the opposite direction. And now the force is going to point upwards. Now to balance a negative electrical field, I'm going to need a magnetic field pointing towards the screen. And that's what we have here. So I'm going to have a negative electrical field. I'm going to play. Now the idea here, if this is a velocity selector, for particular velocities we are going to have this force equal to this force. Purple force is equal to the blue force, or the force due to the magnetic field equal to the force due to the electrical field. When that happens, the charge is going to move in a straight line. If they are not equal, then the charge is going to bend downwards or upwards, so it's going to miss the target. For example, I increase the velocity. See, when I increase the velocity, the magnetic force has increased. Okay, I'm going to decrease the velocity. And you notice here the magnetic force has increased. So you can find an area where these two forces are balanced. In that case, the charge is going to move in a straight line, and it's going to hit its target. Of course, everything is going to change if my charge is negative. everything is going to change, but the overall result is the same. So if I have a -1 charge, the magnetic force is going to point down, and the electrical force is going to point up. Okay, questions you might ask yourself: would the mass affect the forces? As you notice there, it does not. The electrical field force is QE and the magnetic force is QVB sine theta. Neither one of them is affected by mass. The acceleration, of course, is affected by mass, but not the forces. Okay, let's go back to the presentation slide. So using the right-hand rule, B must be into the page if my electrical field is pointed down and my charge is positive. So then my magnetic field should be into the page with a magnetic force pointing this way. For the forces to be equal to each other, the electrical force Q times E should be equal to the magnetic force, which is QVB sine theta. But here, since the magnetic field is perpendicular to the velocity, the angle is 90 degrees. So in that particular case, we have QE is equal to QVB. The Q's cancel out, so you notice it does not depend on the charge. And we have the relationship between B and E. B is equal to E over the velocity. Okay, just for the fun of it, what direction should be point if you want to select negative charges instead of positive charge? Okay, if you would like to select negative charges, then if this is my E, my F sub E is going to point up. So my F sub B should be pointing down. So using the right-hand rule, the thumb should be in the direction opposite to the velocity or towards the left of the screen. FB should be pointing towards the bottom like we have it here. So the magnetic field is still into the page.